Welcome to this video. In this video, we will discuss how to write circuit files in LTSpice in order to perform DC operating point analysis, DC sweep analysis, AC analysis, then step variation in parameters, and finally transient analysis. So first, we will start with the DC operating point analysis. So .op is the command used for doing operating point analysis. So I will illustrate this with the help of a simple example. So there is a circuit consisting of a voltage source and two resistances. So the first step is to label the nodes. So you can use any names for numbering the nodes. It need not be 1, 2, 3 like that. You can name this node as 72 and this node as 24. That is also possible, or you can label this node as N1 and this as N5. Okay, the only condition is that ground is 0 is reserved for ground, and in any circuit you have to mention the ground node or reference node. So here this reference node is labeled as 0, and for simplicity I have numbered the nodes as 1 and other two nodes as 1 and 2. So the first line must be a comment line. First line in the circuit file must be a comment line. Comment line starts with this asterisk symbol star example1. This is a comment line. Then second line is regarding this voltage source. So it is given a name V1. V1 is between 1 and 0. Node 1 and 0. Positive terminal is written first. Positive terminal of this voltage source is connected to node 1. Negative terminal of this voltage source is connected to node 0, and the magnitude is 10 volt. That is written here. So the name of a voltage source should start with V, letter V, either uppercase or lowercase. Then resistance R1, name of the resistance should start with the letter R. R1 is between node 1 and node 2, value is 6 ohm. Then R2 is between node 2 and node 0, and value is 4 ohm. So these three lines completely describes this circuit. And to perform operating point analysis, write .op, and the circuit file is terminated with this .end file. Now let us run this in LTSpice and see the result. So open LTSpice. I have already written this circuit files and saved it in a folder. So I will open that. So you have to type these commands in a text file, notepad, and save it with the .car extension. Then you can open it in LTSpice. So if you open the example one, it will look like this. Then click on the run button. So it will show the operating point values. Node 1 voltage is 10 volt. Node 2 voltage is 4 volt. Current through resistance R2 in this order from node 2 to node 0 is 1 ampere. Current through resistance R1, I of R1 in this order from node 1 to node 2 is 1 ampere. And current through voltage source V1 from positive terminal to negative terminal is minus 1. That is from node 1 to node 0, that is minus 1 ampere. So this is how we can calculate the operating point in a DC circuit. Now let us consider a second example for .op command. So here we have a bridge arrangement. So first step is identify the nodes. So I have numbered the nodes like 1, 2, 3 and 0. So this is taken as a reference node. 0 is a reference node. Then star bridge, this is the command line. First line must be a command line. I have written star bridge. Then V1 is between node 1 and node 0. Value is 10 volt. Sorry, 10 volt. Okay. Then in some books or some others will write a V here. So this spice will ignore this V. It will take only this magnitude. Then R1 is between node 1 and node 2 and value is 5 ohm. Okay. R2, second resistor, is between node 2 and node 0, value is 2 ohm. And third resistance is between node 1 and node 3, value is 10 ohm. Fourth resistance R4 is between node 3 and node 0, value is 4 ohm. Then R5 is between node 2 and node 3, value is 6 ohm. Finally dot op command and dot end. So let us execute this in LT space. So open example 2. So run this. So you can see the node voltages and branch currents. Since the bridge is balanced, the current through branch R5 will be 0 as expected. This minus 1.48 into 10 power minus 16. So this is practically 0. So like this we can calculate the operating point in a given circuit using .op command. Okay. Coming to third example. This is for performing DC sweep analysis. DC sweep means in this particular example we will sweep this source voltage from say 5 volt to 15 volt in steps of 1 volt. So to do that we will start with a command line star example 3. Then V1 is between node 1 and node 0, value is 12. R1 is between 1 and 2, value is 8. R3 is between, R2 is between node 2 and 0, it is 4. Then use this command dot DC, name of this voltage source V1 that you want to vary. Then start value, stop value and increment. 5 is the start value, 15 is the stop value, 1 is the increment. Then you can plot the variable of interest. For that you can use dot prop command, dot prop VF2, then end. Okay, so the important command here is dot DC for doing DC sweep. Dot DC, variable name, then initial value, final value, increment. So let us do this in LT space. So open example 3. So I have already written the code here. First line is a command line. Then the remaining lines are written here. Then if you run the program, you can see the plot of V2. You can see the plot of V2 as V1. Source voltage is varying from 5 volt to 5, 6, 7 in increments of 1 to 15 volt. Okay. So when voltage at node 1 varies from 5 volt to 15 volt, what is the variation in V2 is plotted here. So that is about DC sweep analysis. Coming to the fourth example, this is for AC analysis or frequency response analysis. So a simple circuit consisting of a current source and an LC circuit is given here. So first line is a command line dot star AC analysis. Any command you can write here starting with this asterisk symbol. Then I1 between node 1 and node 0. The positive terminal is connected to node 1, negative terminal connected to node 0. Between node 1 and node 0, use this AC1. Since we are doing an AC analysis or frequency response analysis, we will be keeping the magnitude of the source of excitation constant and we will vary the frequency. So if we are keeping the magnitude at say 1, you can simply write AC1. If you want to keep the magnitude as say 7 ampere, then you can write AC7. Then L1, inductance L1 is connected between node 1 and 0, value is 100 microhenry. So 100 microhenry is written as 100 U. Then C1 is between node 1 and 0, it is 10 picofarad, so it is written as 10P. Then for doing AC analysis, the command is this one, dot AC, starts with the dot AC, then type of variation in frequency. It can be either decade variation or octave variation or linear variation in frequency. Since we are using decade variation in this example, we will write DEC. Then number of points in one decade, number of points in decade, points per decade. Then this is initial frequency 100 Hz or starting frequency 100 Hz, then till 1 megahertz, stopping frequency 1 megahertz, then dot end. Okay, let us execute this in LT space. Open example 4. So I have written the code here. You run the file. we will get a blank screen like this, and right click on this blank screen graph, click on add traces. So here you can see the available data. V of 1, node 1 voltage, current through capacitance C1, current through current source I1, current through inductor L1. Okay, so I want to plot the voltage source V1, frequency response of node voltage 1. Click OK. So you can see the magnitude response and phase response. Magnitude plot and phase plot. So in the magnitude plot, there's a peak here at the corner frequency, and this phase changes from say minus 90 degree to minus 270 degree at this particular frequency. So this is how we can plot frequency response using LT Spice. And coming to the next example, in order to illustrate this again, we will use another example for AC analysis. Here we have an RC circuit, simple RC circuit, low pass filter circuit, and the input is a pulse generator. Before that, we will consider a simple case. Input is a sine wave with magnitude 1 volt. So first line is a common line, and V1 is between 1 and 0, AC 1, R is between 1 and 2, 16K, then C is between 2 and 0, 0.1 microfarad, dot AC decade, 10 points per decade, 1 Hz to 1 megahertz, dot end. So let us run this in LT Spice. Example 5. So you can right click on this white space, click add traces, select V of 2, node 2 voltage. So here we can see the low pass filter response. Initially 0 decibel gain, then gain decreases up to 20 decibel per decade, and the phase plot is initially 0 degree, then finally it comes to minus 90 degree. So this is how we can do frequency response analysis in LT Spice using .ac command. So the command syntax is .ac, type of variations, number of points per decade, starting frequency, stopping frequency. Then coming to the step variation of parameters, we can use .step command. So the first line will be some command line. So step command example is a command used. Then V1 is between 1 and 0. R1 is also same as before. For C1, I am using a label C within curly braces, and I want to change the C in steps from 0.1 microfarad to 0.9 microfarad in steps of 0.1 microfarad. So I can use the command .step parameter PARAM .step parameter, then the label used here in curly braces, that is C, initial value 0.1 microfarad, final value 0.9 microfarad. U stands for micro, and step size or increment 0.1 U. Then AC, do the AC analysis. So let us do this in LT Spice. Example 6. So I have already written the code here, and I will just run. So if you click on add traces, V of 2, you can see the plot of frequency response for different capacitance values. So you can add a legend also here in using this view option, step legend, and you can see the details of different graphs. Okay, this is how we can do AC analysis in LT Spice. And the parameter variation, along with the parameter variation. Then coming to the final example, we are doing transient analysis. In transient analysis, we will plot variation of voltage or currents with respect to time. So here I have an RC circuit, and this is a pulse generator. So first line is a command line star transient, then V1 is between 1 and 0, pulse generator. I will explain this in the next page, what is the syntax of this pulse generator source. Then R1 is between 1 and 2, value is 1k. C1 is between 2 and 0, and I will use a label X for C1. And I want to get the plot for 3 different values, or a list of values of C. So I can use the command dot step parameter X list 0.1u, 0.2u, 0.3u, list out the different values for which I want to plot. Then dot transient dot tran 3 milliseconds till 3 milliseconds. This is a stop time. Till 3 milliseconds I want to plot the transient response. So dot tran. And this can be either lowercase or uppercase. Then dot end. So let us simulate that in example 7. So I have already written the code here. Just click run. Add the plot, add traces. V of 2. We will get 3 different plots for 3 capacitance values. Okay, so these are the 3 different plots of node 2 voltage. Okay. So coming to the syntax of pulse generator, this is what was written in the previous page. So this is the order in which you have to specify the values. Initial value is 0 here. So it starts from 0. On state value is 1 volt. So it is written as 1. Then delay time. So initially if there is any delay, then that time delay can be written here. Since it starts from t equal to 0, say t equal to 0 is here, there is no delay, then delay time is 0. Rise time, from off state to on state, it will rise in 1 microsecond. Then fall time, from 1 volt to 0 volt, it will fall in 1 microsecond. So it will look almost like a pulse, flat sharp edged pulse. On time is 0.5 millisecond. Then total time period is 1 millisecond. This is the order in which the values are entered in this pulse command. Okay, and if you run the code, you will get the desired result. So that is about different commands in LT Spice. So I hope you got a brief idea, basic idea regarding how to write netlist in LT Spice. We will see some more commands in the next video. Thank you.